We're now going to look at integration by parts. So here we have our formula for the integration of by parts, which is the integral of u dv, which is equal to uv minus the integral of v du. And the first step in using the integration by parts is we want to determine our u and dv terms. So here we have our example problem, the integral of x e to the 6x dx. And when we use integration by parts, we want to try to determine which of these two terms, either x or e to the 6x, we want to use for our u. So when we think about that, we want to select a u that is easily differentiable. So here we look at this x, and we know that the derivative of x is 1. And when we look at e to the 6x, we know that the derivative of e to the 6x is going to be 6e to the 6x. So that doesn't really help us. So we'll go ahead and select x for our u term, where we have u is equal to x, and that means our dv term will be the remaining portion of our expression, or e to the 6x dx. And so now we can go ahead and find the rest of our terms by taking the derivative of u. So we'll have du is equal to 1 dx. And we can determine v by taking the integral of dv. So we'll have the integral of e to the 6x, which is 1 divided by 6e to the 6x. The next step is we want to plug in our u, du, v, and dv terms into our formula for the integration by parts. So here we have it. We have the first part, u multiplied by v, minus the second part, which is the integral of v du. And so the first part, we'll just multiply these two terms together. And for the second part, we'll take the derivative, or the integral of 1/6 e to the 6x. And we know that this integral is very easy to do. This 6 will just come out in front and be 1/6. And so we'll get 1 over 36 e to the 6x for this integral here. And so our solution will just be the combination of the first part, uv, minus the second part, the integral of v du. And so that's what we'll get for our solution.